Today we're going to be going over right triangle trig. Now this is worth 27 points on your average SAT, so a heavily weighted concept, definitely know it. Our approach on these is going to be to identify right triangle trig questions. We're going to break down the question, we're going to build a formula to solve them, and then lastly, we're going to solve a practice question together. So how do you identify these? Well, these questions are going to test your understanding of the Pythagorean theorem and SOHCAHTOA. Now the Pythagorean theorem is what we have down here, a squared plus b squared equals c squared. An important note is that we can only use Pythagorean theorem when we have a right triangle. And a right triangle is going to be identified with this little box in the corner. And we can only do SOHCAHTOA when we have a right triangle as well. And so both of these concepts necessitate a right triangle to use. But if we have a right triangle, then our two sides that are not the hypotenuse, or the longest side, are going to be A and B. It doesn't matter which is A, and it doesn't matter which is B, as long as it's the leg and the height. And the hypotenuse is always going to be C. And you can tell which one is the hypotenuse because it's opposite of our right angle. So opposite hypotenuse. So if we take the length of side A and square it, and then we take the length of side B and square it, that is going to equal C squared. Now, for SOHCAHTOA, I'm going to redraw a triangle. So SOHCAHTOA is the way that we can remember what sine, cosine, and tangent mean. So for example, we could have an angle here, and if it's asking us for the sine of an angle, then we want the opposite side, so here opposite, over hypotenuse, which is here. And so this one was 5, and this one was 10. Then the sine of our imaginary angle theta here equals opposite, 5, over hypotenuse, 10. So SOHCAHTOA is a great way to remember this. So for SO, it's sine equals opposite over hypotenuse. CA is cosine equals adjacent over hypotenuse. And then TOA is tangent equals opposite over adjacent. So here's a formula we're going to use for right triangle trig. First, we're going to identify what's being asked. Secondly, we're going to apply the correct trig formula. And then third, we're going to match the answer choices. So here's an example. In the triangle LMN above, LM equals MN. And then it asks us, what is the value of sine of NMO minus cosine of MLO? Okay, so we can start by knowing that this is going to be also a right angle because these are supplementary angles. And so we have to have a total measure of 180 degrees. So if one side is 90, the other has to be 90. It also tells us that LM and MN are equal measure sides. And so if we have two sides that are the equal measure, then our third one is also going to be equal measure. And we have three sides of the same length, which means we also are going to have three angles of the same length. And so these are actually congruent triangles. Now, let's look at what we're asking. Sine of NMO. So let's do sine of NMO. And this middle one right here, whatever angle's in the middle is the angle we're looking at. So NMO, we're looking at M, so we're looking at this angle right here. And we're looking for sine. So we're looking for opposite. So opposite is NO. See opposite over hypotenuse, which is this one. So NO over NM. And this we're going to subtract from the cosine of MLO. And so now we're looking at this L angle. And cosine adjacent, so right here, LO over hypotenuse, which is going to be over here, LM. So if we're looking at our two triangles, NO over NM is actually just the same as LO over LM. They're both taking our bottom side and dividing it by our hypotenuse. And so if we're dividing the same two legs, then subtracting them is going to be equal to 0 because they're the same exact value. So to reiterate, in this one, we actually didn't even need to know any of our side lengths because we know the sides are the same length and we're taking proportion of the two same sides for both the NO over NM and LO over LM. And so if we're taking the same proportions of the same sides, they're going to equal 1 each, and 1 minus 1 is just going to leave us with 0, which is why B is correct. So good luck on these.